I keep getting questions about dark matter. I don't know what to do.
So that's why we'll be talking about dark matter halos today. Dark matter is difficult for us to observe with just our eyes because it does not interact with the electromagnetic forces. Normal matter can either reflect or absorb light. In this case, the energy reflected, such as the pink, red, and green, will be the colors we can visually detect. However, this is not true for dark matter. Another interaction would be emission, something electrons do as they pass through the filament of a light bulb. Yet again, however, this does not apply to dark matter. Essentially, this means that it cannot absorb, reflect, or emit any light, making it very difficult for us to analyze its behavior and patterns. It's a very stubborn thing. However, as its name implies, it is matter, and all matter must be massive. So, to work with dark matter, researchers look towards how it interacts with gravity. As in space, if the mass is significant enough, it will bend or distort the gravitational field. For example, if you stretched out a blanket so there's a good amount of tension, and then you place a ball, it'll warp the blanket to dip under it. This gravitational lensing is the leading reason as to why we know dark matter exists and makes up around 85% of all the matter in the universe in what scientists believe is a cosmic web. So, a dark matter halo is a region of dark matter that encases galaxies in clusters and generally spans much further than the galaxy's reach. Essentially, they have smaller dark matter subhalos surrounding it, ultimately providing scientists insight on how galaxies have formed and evolved. This comes from additional gravitational disruptions that can affect the accretion of gases necessary to form cosmic objects within the envelope. Their distribution is a key in understanding this formation. Their distribution is a balance between the accretion of the newly formed subhalos and the disruption of older ones. This disruption generally comes in the form of tidal forces that occur when another massive object passes nearby. This effectively causes a stretching that pulls apart the halo's dark matter particles. To get the data, researchers run simulations of the dark matter in galactic systems. Knowing how dark matter subhalos are distributed around their hosts is extremely important in understanding the early background of the birth behind many cosmic structures such as galaxies, as, like I mentioned earlier, the accretion of gases is what forms these galaxies. That will be it for today. Thank you so much for sticking with me.